Here we're using the control voltage library to put values into a sequencer and trigger a sequencer and then output those as control voltage. So here we have two different signals. One is a trigger signal, which is happening in sync with the sequencer being triggered. And then we also have the CV coming from the sequencer. And then we have a sequencer object, which is holding the actual sequence. Using the ESP32 DAC again, here in our setup function, we were filling the sequencer, and actually I'm just filling it with values from 0 to 15, right? So the sequencer is a 16-step sequence that just goes 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 16. 8-bit DAC again. So, okay, in our main loop, we are calling our loop on our signals. Now, the sequencer doesn't need to be generating a sample every time, right? Because all the sequencer is doing is just stepping through 16 saved values. So there is no sequencer.loop function happening here. But instead, inside our control loop, we're going to be triggering our sequencer. And when we trigger our sequencer, we're going to return the current sequencer value and then also update the step. So actually what happens is when you trigger it, it goes to the next step, and then you get the value of the new step, output of the seek.trigger. And in this instance, we're doing two things with our signals. We're triggering making a trigger on channel 1, and on channel 2, we're sending the output of our sequencer as a MIDI note into our channel 2 to make a quantized CV. So that's why our sequencer.trigger right now is just going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to make a chromatic scale as MIDI. Notice I'm also offsetting by 24 because sort of the lowest MIDI note you'll probably likely want to use is 24. It's pretty low. There's really no reason for that. I'm actually thinking I might just get rid of this and just have MIDI note start at 0 because you can always scale the output of the quantized control voltage in your modular synth. One other thing we're doing in our control loop is we're monitoring our sequencer to see if the sequencer has reached the end of its cycle. So there's a flag when you get to the last step of the cycle that you can check. And if we have reached the end of the cycle, we can, run a function to do some arbitrary operation on the sequence or anything else. So in this case, what we're doing is we're changing the range of our sequencer. So by default, it's a 16-step sequencer. It's going to go from step 0 to step 15. But we could decide that we want to make it go from step 2 to step 13, for example. And so here, every time we get to the end of a cycle, we're going to increment our start step, and we're going to decrement our finish step. So it's going from 0 to 15, from 1 to 14, from 2 to 13. And you can see that in the CV, the range of the sequence is going to get progressively narrower. Takes a while to get there, but you'll see the lowest step is kind of getting higher and the highest step is getting lower, and then at some point it becomes very narrow. And then it reverses. So if you set the start point to be a later part than the finish point, the sequence will play back in reverse. So let's listen to that. You hear the sequence get longer as the range increases, and now it's going to get shorter. It's always really fun when it crosses over to go reverse. All right, so that is controlling our sequencer and our signal loop. It's actually going to look very similar. We're getting the values from our two CV channels. We're converting to 8-bit quantized. And again, this is kind of a hack because the DAC is really nonlinear, but it seems to be reasonably in tune. Writing those values for our DAC and then writing them into our serial plotters so we can monitor them. Now in the make noise no coast, the envelopes are kind of weird. If you increase them, they'll start ignoring triggers until the envelope is finished. So the variation in these two clocks is really just because of the no coast. They're still getting the same trigger signal. You can see this is the trigger signal coming directly from the ESP32, and this is just multing it out to both of these modules. Anyways, lots of fun. Just another example.